Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in previous lecture we have completed some problems on a dominance property. If there is a m by n types of games, then we can reduce that m by n games into 2 by 2 pair of matrix by using dominance property we have seen in previous lecture. So in this lecture we will see if the game is 2 by n or m by 2. Such types of game can be solved by using graphical method. So in this lecture we will see the graphical method for 2 by n and m by 2 games. That means 2 rows and n columns and m rows and 2 columns. Okay. So before going to start problem, we will see what are the main step of the graphical method. How to solve the 2 by n or m by 2 games by using graphical method. So what is the first step? Check whether if saddle point exists, then optimal strategies are pure strategies. If saddle point does not exist, then go to second step. Okay. Suppose if there exists a saddle point, then this problem become as a first type of the problem. That means uh, which which problems which represent saddle point exist. The games is saddle point. Second step is check for column row dominance every element dominated column or row. This state is used only for the reduction of the size of the game. Then we will check the dominance property is applicable or not. Okay. Then write down constraint for the column or row of the pure matrix. Then plot all the points on the graph and identify feasible region which satisfies all the constraint. Okay. Next step will be the select a highest or a lowest for a row. Interesting point, intersecting point in the feasible region and write down the subject for the selected point. Then solve the game by usual method 2 by 2 method. So here you have to note that 2 points. If row less than column, so in that case we will choose lower region and select highest level point. If row less than column, then in this case we will choose lower region and select highest level point, and that point is called as a maximum point. Second condition, if row greater than column, then we will choose upper region and we will select the lowest point, and that point is called as a minimax point. Okay, so these are the some steps of the graphical method. Now we will see one problems on a graphical method. Okay, so what is the first problem on a graphical method? Solve the following 2 by 3 game by using graphical method. So this is a player A and this is a player B. Okay, so player A using two strategies A1 A2 and player B B1 B2 B3 with P of, this is a P of matrix. This is the 2 by 3 P of matrix. Now we will see the solution of this 2 by 3 P of matrix. So write down the given P of matrix. Okay, so this is the given P of matrix. So here we will find out the first row minima. If row minima means select lowest element from each row. This is 2 and this is 2. That is a row minima. Find out the maximum. Maximum means largest value in a row minima, and it is denoted by lower v bar equal to 2. Find out column maxima. Column maxima means select maximum value from each column, that is 7 that is 5, and that is 7, that is 11. Okay, then find out the minimax. Minimax means lowest value in column maxima, smallest value in column maxima, that is it is denoted by upper v bar and which is equal to 5. Okay, so dear student, if you observe from the given pair of matrix, there does not exist any saddle point. That means this is games is without saddle point. Okay, so the given is 2 by 3 game cannot be reduced by the dominance property. If you check here dominance property, the dominance property cannot be reduced this 2 by 3 pair of matrix into 2 by 2 pair of matrix. Okay, so here the dominance property is fail. Then we will solve this problem by using graphical method. Okay, so first of all we plot all the points on a a1 a2 axis as shown in following figure. Okay, let us we draw the all the points on a1 a2 axis. Okay, so let us we take a1 axis, then a2 axis. Okay, so 0 1 2 3 4 up to 11, 0 1 2 3 up to 11. Okay, so on a1 there is a point, there are a point 2 3 7, that means the number should be 0 to 11. And on a2 axis there are number 2 to 7, so we can take uh, 0 to 7. Okay, so for the simplification or for the equality we can take the 0 to 11, 0 to 11. Okay, for the same number. Okay, so take a1 axis and this is a2 axis and this is the 0 means origin point. Okay, now we will draw this point 2 7. 2 means on a axis, a1 axis, 7 means on a2 axis. So where is 2 on a1 axis? So this is the 2, this is a 2, this is a a1 axis. Okay, 2 and this is 7. Okay, this is a 2 7. Okay, and then join this line and this is the line is b1, that is 2 7, that is 2 7, b1 line, that is 2 7. Similarly we will draw this line a1 axis, that is 3, a2 axis, that is 5. Where is a1 axis? That is 3, this is the 3. Okay, and a2 axis, that is 5. Okay, then we will join this point a 3 and 5 and this line will be the b2 b2 3 5, that is b2 3 5. Similarly we will draw this line b3 line, that is point is a1 is 11, a2 is 2. Okay, so a1 is 11, so this is a1 on 11 and this is a2 on a2. Then join this line and give the name, that is b3, that is 11 3. Okay, so in this way we can draw the all the points by plotting all the points on a a1 a2 axis, then we will draw the lines. Okay, now we will find out the region, which region will cover this graph. Okay, so we have already seen the note, if row less than column, if row less than column, then we can say that if row less than column, then we can choose a lower region and select highest level point, that is a maximum point. Okay, so here row is 2 and column is maximum. Okay, so here first case we will apply here. Here row is 2, that is, and column is 3, that is row less than column. Therefore here we will select lower region and we will select the highest level point. Okay, so from this graph we will select this lowest envelope, or we can say that this lowest part of this graph. So this is called as a lower envelope, lower region. Okay, and this is the first point, second point, and third point, and this is fourth point. So this graph or this feasible region join to attached to 4 points, 1 2 3 4. So from this 4 point we will select a highest level point. So that is highest level point, this is point. So let us we denote as this is a p point, unknown point, and this is a q point, that is also unknown point. So this q is a highest level point in this lower inner lobe, and that is point is called as a maximum point. Okay. Now we will reduce by using, now we will reduce the 2 by 3 p of matrix by using this maximum point. Maximum point is the intersection of b3 lines as well as b2 lines. So this maximum point reduces p of matrix, that is b2 line and b3 line, that is 3 5 and 11 2, and a1 a2 axis as it is. Okay. So on a1 axis that is 11 and a2 axis that is 2. Okay. So this is the reduced p of matrix. Okay. So q2 is a b2 and b3 intersection point, that is maximum point. So therefore we can say that the given p of matrix can be reduced in this form. Okay. So here we will find out, now we will solve this p of matrix by using usual methods, that is 2 by 2 p of matrix. So here find out row minima. Row minima means lowest value in each row, that is 3, and here 2. Maximum means highest value in row minima, that is 3. Okay. That is 3. Okay. Column maxima, that is a maximum value in each column, that is 5, and this is 11. So find out minimax. Minimax means lowest value in column maxima, and it is denoted by per v bar, and which is equal to 5. Okay. So if you observe again from this 2 by 2 p of matrix, there does not exist any again saddle point. There does not exist saddle point. That means we can say that this 2 by 2 p of matrix is used mixed strategy. Okay. So for that we will consider the mixed strategies are: optimum strategy for player A is A1 A2 with p of P1 P2, and optimum strategy for player B is B1, B2, B3 with P of Q1, Q2, Q3. Okay. So if you observe from this, here B1 is absent, so therefore Q1 will become 0. Okay. So here conditions will becomes P1 plus P2 equal to 1 and Q1 plus Q2 plus Q3 equal to 1. But here Q1 is 0, so this will becomes, that is Q2 plus Q3 equal to 1. Okay. So from the given P of matrix, A11 means 3, A12 means 11, A21 means 5, A22 equal to 5. We have already seen in previous lecture or before that lecture. Now here we will find out the P1 and P2, then Q2 and Q3. And we know that the formula for P1, that is A22 minus A21 divided by A11 plus A21 minus A12 A22. Okay, this is a A22. This is a A22. Okay, so putting all the values in this term and solving, you will get 3 upon 11, that is the value of the P1. Then we will find out the P2. P2 means 1 minus P1. So 1 minus P1 means 1 minus 3 by 11. So you will get P2 is 8 upon 11. Okay. Similarly, we will find out Q2 and Q3. So we know that the formula for Q2, A22 minus A12 divided by A11 plus A22, A11 plus A22 minus A12 plus A21. Okay. So putting the values in this term, we will get 9 upon 11. This is the Q2 terms. And we know that Q3 is find out, that is 1 minus Q2. So that is after solving you will get Q3 is 2 upon 11. Okay. So in this way we have calculate here P1, P2, Q1 is 0, Q2 and Q3. Okay. So therefore the optimum strategy for the player A and for player B can be written as SA. A1, A2, P1 is 3 upon 11, A2, P2 is 8 upon 11. SB, optimum strategy for player B, B1, B2, B3, Q1 is 0, Q2 is 9 upon 11, and Q3 is 2 upon 11. Then finally we will find out the value of the game. V is A11 into A22 minus A12 into A21, A11 plus A22 minus A12 plus A21. This is the formula for the value of the game. So putting all the values from the given 2 by 2 pair of matrix and then calculate addition, subtraction and cancelling. So you will get V equal to 49 by 11. So this is the value of the game. Okay, so this is the complete problems on a graphical method. So these are the optimum strategy, mixed strategy for player A and for player B, and this is the value of the game for the player A and for the given pair of matrix. Okay, so in this way we can solve the problems by using graphical method.